and false negatives. So false positive being a bug that the tool reports that actually isn't present in the program, and a false negative being a bug that is present in the program that the tool does not report. Both of these can be caused by having an incomplete or inaccurate model of the program. Clearly a false negative, if you didn't understand that block of assembly code embedded in your C program, then it didn't make it into the model, and the analyzer isn't going to find the buffer overflow that's in the middle of it. On the false positive side, it's a little more complicated. So an example might be the analyzer didn't understand that a call to request a get parameter is always going to return the same value in the same thread in a web application. Now, if you call request a get parameter and have an if block that checks if it's null, and then later dereference that value inside that if block, you've guaranteed that it's not going to be null, but the analyzer might not understand that and might report a false positive. Missing rules can also cause both false positives and false negatives. If you haven't described the right attributes of the APIs that you're analyzing, or if you haven't described the vulnerabilities that you're interested in finding, then you could have one or the other. And finally, there's this idea of conservative versus forgiving analysis. So if I find a bug, but I can't prove that it's a bug, I think it could be. Maybe there's a runtime value involved that if it were true, then it would be a vulnerability. If it's false, it's not. Do I report that or do I not? So conservative analysis, which is typically what we see in security tools, will report a vulnerability if it thinks there's a possibility of a vulnerability being present. A forgiving analysis, which you see more in the quality side, will report bugs when it's very, very confident that the bug is actually a real, true positive. And finally, displaying results. So we talk a lot about accuracy of analysis, weighing false positives against false negatives, but a lot of the effectiveness of a tool in a real enterprise or other code auditing environment has to do with how the results are presented to the user, how effectively they can triage those and make decisions about which ones are interesting and need to be fixed and which ones aren't. The right interface for a developer is not necessarily the right interface for an auditor who's unfamiliar with the program or for a team of developers who are looking at an entire code base. So it's critical to think about what the interface you're presenting to the user you have in mind is. If you guys want to give this a try, we have a project called the Java Open Review where we analyze open source projects and present the users back to the development teams, present the results back to the development teams responsible for them. We won't show you all the vulnerabilities in the real open source, decent disclosure and all that, but there are some samples like the web code application from OWASP that are up on the website. You can play around with one of these interfaces. So how do you use static analysis in practice? There are kind of two models in which we see the tools used. One, and this is where everyone begins, is you've got some piece of software that's already implemented, or maybe you're towards the tail end of implementing it, and you decide to bring in a static analysis tool and start reviewing it for security problems. This can present a real hurdle up front because you have a lot of code, maybe it hasn't been developed with security in mind. You bring a tool and it's going to report tons of issues and you have to decide how to deal with those. Some of them you won't fix, some of them you will, some of them you'll put off until later. This is a great place to kick off a process. So maybe you've got a development organization that doesn't know just how bad things are. You want to bring a tool in and explain to them, look, here are the 10,000 problems that you have in your software that you need to fix. But it's not really the place you want to be for long because you're going to have this insurmountable barrier of tons of things. The better place, and to move into the second model, is as you're writing code, you're analyzing it. So you fixed that initial big bunch of bugs you found, and now you're only looking at deltas. So as you reach a new development milestone, you run a scan, you only have to fix the problems that were introduced in that new little bit of development. And this is where eventually we'd like everyone to get. So next I'll talk a little bit about some, we've been building static analysis tools for 4 or 5 years now. We've talked to 300 or 400 large enterprise customers, and we've got some ideas about how to make them work most effectively. So these are really steps to adopting a tool. How do you make the process work? What do you do in practice? These tools, unlike many other development tools, really require a change in culture, a change in process. For the most part, they represent the first point that we've started considering static analysis in a given development process. And because of that, you can't just throw them over the fence and expect them to solve the problem for you, just like the chainsaw isn't going to cut down the trees. A problem here is exactly that, and often that the tool gets rejected. So you throw it over the fence and say, I want you to start thinking about security, and they say, oh, the tool found 10,000 problems, I don't want to look at those. So this is one to watch out for. Next is defining the playing field. And this has to do really with defining what the goals for the process initially are. So you're not going to fix all the problems. You're not going to make your software secure overnight. So what are the milestones, just like in a development process, that you want to attain? Maybe it's fixing all the high priority issues. Maybe it's fixing all of a certain class of bug that's been a problem in the past. Whatever it is, define that milestone, put a gate in place to see whether you've reached it, and then evaluate what you've done so far and either change things or move forward. Don't just expect the tool. So I said before that the tool brings security knowledge along with it, which it does, and that's fantastic. Don't expect the tool to do all your training and education for you. So you can't give it to someone who knows nothing about security and expect it to solve the problem there either. Train people on the tool for certain. They can be kind of complicated like any other development tool, but also educate them about security. And I think that's an important difference there between training and education. You train people on what to do. You educate them about why they're doing it. Don't try to conquer the world all at once. Start small, pick a friendly development team, roll the tool out to them, see how it goes, learn from your mistakes, and then expand beyond that. It's amazing how relevant a reference from an internal group, someone you trust, appear on the tool's effectiveness, how you can use it best, is compared to an outsider coming in and say, here, you're going to use this. So my team is responsible for developing all the rules and the categories of vulnerabilities that Fortify looks for. We pride ourselves, in fact, in now we find 225 different kinds of distinct vulnerabilities. Don't look at most of them up front. Turn 90% of them off. Think about the ones that are important for you and address those first. That's a way to reduce that big burden of initial bugs, and then ratchet it up from there. Appoint a champion. This person might be called an architect in some companies. It might be a developer who is just really interested in new technologies or already has some experience with security. Whoever this person is, think of them as a champion for the tool, have them build up expertise with the tool, and then act as a resource for their peers. So we talked about defining a gate, so making goals explicit up front. And in order to determine whether you've reached those goals, you need to be able to measure the effectiveness of the process and the tool. So come up with reasonable metrics. Don't just measure what the tool found. I think more importantly, measure which of those things got fixed. How long did it take to fix them? This one is near and dear to my heart. I think 99% of the people using static analysis today are not getting as much out of it as they could be because they haven't invested the little bit of effort necessary to customize it for their environment. Make it understand what's important to them. Make it understand their security frameworks or APIs that they use that are proprietary to their software. A little bit of customization will go a long way there, and particularly when it enforces internal secure coding standards. So the perfect model here is standards are written to accommodate what the tool is effective at enforcing, and the tool is used to enforce the standards so that if people maybe forgot their training 9 months ago, the tool is going to remind them a little bit about what where they went wrong. This one is one that bites our customers quite often. So you get the tool, you put it in place, and all of a sudden it's adding a huge overhead to your development process. And you think, oh, I can't keep doing this, it's costing me too much money. The first time is going to be much worse than subsequent times. You're going to learn lessons as you get used to the tool, as people have been through the training, as people learn when to trust the tool and when not to. Our numbers, and Microsoft has numbers to support these, show that the first time around is usually twice as expensive as subsequent iterations, and that the first time, that in general, adding software security will add about 10% overhead to an existing process. So I've got a whole nother talk that I give on software security metrics, and you could easily spend a day talking about them, although they're not particularly well developed today. I'm going to spend a slide on it today. The most common metric that people like to apply to static analysis or other software security activities is defect density. It's one that we've used in quality for a long time with good results. I argue that it does not apply well to security because it's very difficult to measure. Sorry, it does apply, but not in the way people want it to. It doesn't measure risk. So it's very hard to attribute the amount of risk that one vulnerability in a million-line application might introduce to the organization. So don't use defect density as a metric for measuring